Hey, what's going on, guys? In this video we are going to see how to solve a separable differential equation. Separable differential equation is one of the easiest differential equation you can solve. Here what we have to do is we have to separate x and y and then do the integration. Okay, x to one side, y to the other side, and then we do the integration. Now first you have to see which one is on top. So if you have dy is on top, you have to bring this y to this side. Okay, and dx in the denominator, dx is in the denominator, so we bring this dx to the other side, so that will be in the numerator, and also we have to bring all the x terms to the other side. Now let's go ahead and do that. If I bring this y to this side, this is going to be just 1 over y dy, and if I bring here, we already have an x, and I bring this dx to this side, dx in the numerator, and here we have x square plus 1 in the numerator. If we bring this to this side, it's going to be in the denominator. Okay, now after we bring this one to, like, we separated y and x to each side, right? We separate y and x, and then we do the integration. That's it. Now we do the integration. Integration of 1 over y is just ln of y, and in the other side we have this integration. Here we can do the u substitution. Let's take u as x square plus 1, x square plus 1. You can recognize this is a u substitution by looking at when you have x square, and if you take the derivative of that one, you will end up with 2x dx, right? So we have x, it means 1 less power, it means we can do the u substitution. So in that way we can figure it out easily whether we can do u substitution or not. Now here we can take u as x square plus 1, therefore du is going to be just 2x dx, and then we can write everything in terms of u. If we do that, we know that 2x dx is equal to du. Here we have x dx. To replace x dx, we can bring an equation. Du divided by 2 is equal to x dx. I derived from this one. Okay, so instead of x dx, we can plug du divided by 2. So 1 over 2 is a constant. I move that one to the front, and then du I keep it right here. I replace x dx. Now x square plus 1, it's equal to u. That's in the denominator, so this is 1 over u. Okay, now let's go ahead and do the integration. Ln of y is equal to half integration of 1 over u, that's ln of u. Now we can replace the u with x square plus 1, so this is going to be just x square plus 1 right here, and then we have to add a constant. Okay, now finally we have to express our answer in terms of y. Here we have ln of y. To get rid of this ln of y, we can take e power both sides, and if I take e power both sides, e and ln cancels each other, we get y, and in the other side we have half ln of this one. So whenever we have half, like whatever number here, we can move it as a power. So if I do that, e power ln x square plus 1 power half. Okay, power half. Now here we have a constant, plus constant. So whenever you have x square times x power 4, you know that the powers will add and you will get x power 6. Same approach goes to here. When we have power adding, it means it's a multiplication. So you can separate this one as e power c. Okay. Now the next thing is, here also e and ln cancels each other. So we will get y is equal to e ln cancels each other. We get x square plus 1 power half. That is basically square root. When you have power half, that is basically square root of x square plus 1. And instead of c, you can write it as a constant. Like you can say e power c is another constant, that's a, and put a right here. And finally that's our final answer. Okay, that's our answer, general solution for this differential equation. I hope this helps, and if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.